About those if the lines are parallel?
They're congruent.
Yep, they're congruent also. What does congruent mean?
Equal.
Yeah. So we have alternate exterior angles, which would be angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. That's congruent. Have I not drawn that yet? This means congruent. An equal with a little squiggly above it. Alternate interior angles. Our angle 3 is congruent to angle 6. And angle 4 is congruent to angle 5.
One is 6 and
3 and 6.
oh.
2 and 7, they're up there. Okay. Questions so far about any of these two? So I think until right now we've learned linear angles, we've learned vertical angles, we've learned... there's been a couple that we've learned. But anyways, this is today. Everyone ready? Ready, spaghetti? Okay. I'm going to start off actually kind of tough because, well, look up here. If I'm told that this is 120 degrees, angle 8 would be 120 because of alternate exterior, right? Angle 5 would be 120 because of corresponding. Angle 4 would be 120 because of vertical, right? And then we could get 2 by subtracting from 180. Remember, linear angles are supplementary. So I know that's going to be 60.
You need a video of this.
It is. That's going to be 60, that's going to be 60, and that's going to be 60. Right? Now, all these we can measure based upon these theorems. So we've learned a bunch of different ways how angles relate. Right? We've learned alternate interior, alternate exterior, corresponding, we've learned linear, and we've learned vertical. Those 5 ways, you can find the angle measure of just about any angle in these kind of diagrams. Okay, Maddox.
The only way you can is if those two aren't parallel, right?
Yep, if these two aren't parallel, so for example, if you happen to have one that's like this, and they tell you this is 120, right?
Yeah.
The only ones you know are this is 120, this is 60, this is 60, but you can't find those because...
Do you even know that that's a perpendicular line?
What?
Do you even know that that's perpendicular?
Yeah, if there's a line that cuts through another one, it's not perpendicular, but we know that this plus this has to be 180.
Yeah.
No matter what, right? So you could find those, but you couldn't find those. Because these would be a different measure than the other ones. Carter, turn around. Okay? Alright, let's do a couple examples you're going to see today. You see that shot? JR? You moved the trash can. Okay, here we go. Let's make the transversal like this. And our parallel lines like this.
Can you do this in our journals? Or?
Yeah, I would draw it inside your journals. If I'm told that this angle right here is Z, this angle is 6x minus 87. Okay. And this angle right here is 63. Okay, the things they want us to find are x and z.
What is 6x minus what?
87. Okay. So we know a couple things about this diagram. In this case right here, we know this angle is congruent to that angle. By what theorem do we know that this angle is congruent to this one? Alternate exterior. So we can, if they're congruent, it means they're equal. So what we can do to find x is set those two equal to each other and solve. So we can go 6x equals, is that 150, 150? Divide by 6, x equals 25. So we know what x equals. Now, once again, we know these two are equal because of alternate exterior angles, right? Yeah, I think you guys probably learned this in 8th grade, if I remember right, alternate exterior.
Yeah.
So alternate exterior. Then how can we find z? Somebody is going to tell me, Maddox.
180 minus 63.
Okay, so perfect. So there's a couple different ways. That's the way I would have done it too, but there's two different ways. We know if this is 63, that angle right here is also 63, right? So you can just go 180 minus 63 to get 117. Or what's another way you could do it? Yeah, you could plug in 25 for x, figure out what that would be, which would be 63, and then subtract it from 180 to get there. Okay, so there's a couple different ways you can go about doing it. If you want to see it that way, you can go 6x, 6 times 25 minus 87, 150 minus 87, 63. Subtract from 180 gives you that one. Okay? Questions on that one? Okay, I'm going to let you guys try one of these on your own. Becca, we're going to do it like, we're going to draw a line like this, and then we're going to draw our parallel lines like this. Becca, how great are those parallel lines? Amazing. Those are base now. 80? Just because you said that, I'm going to throw 80. Nope, not there. Yep, nope. 80's not going to go there. 80's going to go here. This is x. 6y minus 82. I want you guys to solve for x and y. X is not 80. Don't put 80. No, they're not. If it was this angle, then they'd be equal. Figure it out.
Those two lines are parallel, right?
Yep. They tell you they're parallel. They don't have these little marks. They're going to tell you they're parallel. Huh? No.
6y minus 82 equals 80, right?
Oh, maybe.
You're right. Huh?
Maybe. Try it.
But that doesn't work.
We're going to do it together, so just go ahead. Okay. Which one did you guys find first? X? X is really easy. How did you find X?
80 minus 180.
Yeah, so if this is 80, I know that's going to be 80, right? Which means that subtract 180 gives you X, which is 100. Okay? Okay, what do you set this equal to? 80. So to better get Y, we're going to set it equal to 80. So we're going to add 82 to both sides, which gives us this. And then you do this, 30 point what?
It's 27.
I'd try it again. I think it is this right? 162 divided by 6? 27? I think you guys went 182.
Oh, maybe.
Okay. So, any questions on that? Okay. Last one you're going to see today is when you have two sets of parallel lines that all intersect each other. So what you're going to see is a pair of parallel lines like this. And then you're going to see this. Okay, these are parallel to this. And that's parallel to that. So, listen, if you see something like this, and I'm told that this is 77. If I'm told that this is Z, and I'm told that this angle right here is 3y minus 22. Okay. Which variable would you guys want to solve for first?
Z.
I'm okay with either. But I'm going to tell you what I would do on this problem. Is I would list everything I know. I know if this is 77, I know that's 77. How do I know that that's 77? These are alternate exterior across this transversal. So I can subtract this from 180 to get 103, right? Right? Because if you ignore this bottom half, this and this are alternate exterior angles. Well, I also know this is 77, which means this is 103, 103, 103, and 77, right? Am I right so far? What's this one down here?
103.
103. By what theorem do you know that?
Alternate.
Yeah, alternate exterior. If this is, now you're ignoring this, because now you're looking at this transversal. That's 103, this is 103. That's 77, this is 77. Which means that. So we're getting closer to what we're going to set this thing equal to, but you could see it from the very beginning what these two are equal to. But if you needed to, you could list it all out. If this is 77, that's 77. That's 103, 103, which means this is equal to 77. You guys see that? You don't have to do all that to be able to figure out what it's equal to. You guys could have saw here, if this is 77, that's 77. Because that is 77 by corresponding, and that's 77 by corresponding. So you can do this to get 3y equals 99 or y equals 33 would be your solution. Now, there's a bunch of different ways to do it. But anyways, any questions on any of those? Ryan?
So why isn't the 77?
Because this is 77,
So
alternate would be 77. Alternating across the transversal, then linear angles.
alright, yeah, I would just
If you look at it like this, they're not different. Look at it like that. Here's your parallel lines, right? If this is 77, across it's 77. If this is 103, across it's 103.
alright. Okay, thank you.
Okay? Alright. Before I give you guys your homework, I'm going to talk to you a little bit about it's good stuff. So, recently, well, this weekend, I had my brother-in-law come over. And I've been talking to a couple of my classes about this, but I think it's awesome. So my brother-in-law is an electrician. Man, my contact is driving me bonkers today. My brother-in-law is an electrician. Now, electrician is one of the best jobs I think that's out there. In fact, watching him work this weekend, it made me think in an alternate universe I'd have been an electrician. Now, is anyone's parents an electrician? Really? Oh, cool. So, I know that electricians. So my brother-in-law is talking to me. So what we did is we got all new lighting throughout my whole house. Well, my whole basement and then my living room upstairs. And so all day Saturday, I sat there and watched him work. He worked for 12 hours straight Saturday. And I watched him work. And the whole time I'm sitting there talking to him about his job. And anyways, and as I'm watching him, he's doing all this kind of math, right? He has to know how to use formulas. There's this thing called Ohm's Law, which is over my head. I mean, if I could ever look at it and study it, it'd be awesome. But anyways, I'm watching him work, and he's doing some amazing stuff. So I start talking to him, right? And I go, man, what do you, so I mean, he's family, so he doesn't charge me as much as they charge other people. But I go, what do you charge somebody if you were to come in and do what you're doing at my house? And he said, anywhere from like 50 to 80 bucks an hour. And I was sitting there thinking, and he goes, that doesn't include equipment costs. Now, the equipment to do all my stuff was like $300. I mean, if you're charging someone 80 bucks an hour, it's not, that means you're making $1,000 in a day. So my little plug for you guys is and that's him as a journeyman. So he's not a licensed electrician. To become a licensed electrician, you have to go to school and get a degree in electrical, it's like electrical engineering or something. And what's cool is I was talking to him, and girls, there's a lot of electricians that are girls. There's starting to be more and more. Now I can tell you this, that in terms of things you'll need in your life, at some point when you get old and you buy a home, you're going to need an electrician, right? I mean, watching him work and do the things he was able to do was pretty amazing. I mean, did he make mistakes? Sure, but I think everyone. I saw the arc. They call it a blue arc. So he had a hot wire. So he wired up our whole ceiling in part of our basement. And when he went to turn the breaker on, which is highly disappointing, I figure, he's like, all right, turn the breaker on. I turned it on. He turned the switch. None of the lights turned on, right? Which means something was wired up wrong. So he starts taking it apart, and I'm now down in the basement. I'm like, whoa, his name's Joseph. I'm like, Joseph, dude, the power's still on. He's like, it's fine. And anyways, he's touching the hot wire, and all he had to do is like touch the metal end of the wire, and anyways, he gets a massive, right? And I'm sitting there like panicked, sitting there watching him, because I'm like, if he touches it, he just like grabs the hot wire, just not the metal part, and like bends it out of the way. But he's sitting up there working, and he has these metal pliers, and he gets it, and they just get too close, and you could actually see an arc come from the hot wire over to his metal pliers, and right before it hits it, he drops his metal pliers, and the arc goes, like, you just see it disappear. But when the arc hits the metal, apparently there's a big bright blue light. It was just kind of, that was wild. And there's a big, like an explosion sound. That's the explosion you hear whenever power hits power. But my deal here is, this is a legitimate profession I think a lot of people need to start going into. This is kind of a way of the future. I mean, you think about inside of your house, how much electricity runs throughout your house? Everything, right? Everything was ran on electricity. So I don't know. It was amazing watching him work this weekend and helping him out as much as I could. I actually tried to learn, because man, this would be so beneficial if I could fix if something breaks in my house electrical, if I could fix it. So he was trying to teach me, but I was like, that's probably like you guys when you guys learn something that's extremely hard. I would start spacing. I was the worst kind of student. I was like spacing out, like, what's that going on outside the window? Right? Squirrel. But he was pretty amazing. I was really good at. He had to cut holes in my roof, my ceiling in my basement, to be able to like fish the wire, because you had to cut holes and drill through the beams. That was wild watching him do that. But it was a lot of cool stuff. He had this drill bit to be able to get the can light. Does anyone have can lights inside of their house? They're like the recessed lighting. Most people do. But he had a drill bit that was like that wide, and he would just go into my roof and cut out huge chunks. And I thought I was upstairs when he started doing it, and the whole house started like shaking. Like, really funny thing, most people have blown-in insulation in their houses. In fact, probably a majority of you do. When he was doing my upstairs, he only did my living room upstairs. But when he was doing it, we had blown-in insulation up there, and he cuts through it, pulls it out, and a bunch of insulation just covers him. He was not happy. It went all over down his shirt, and he was started itching like crazy. He was not a happy camper at that point. But I told him the old school does, but this one didn't. He would have been itching for weeks. Pain, itching. So, anyway, that's my 2 cents. If you want a good job, that's a great job. I can't even imagine. I don't know how much I make as a school teacher. I probably need to break it down sometime an hour. I know I don't make that. But he says his boss makes his boss, which is the licensed engineer, makes like $120,000 a year. That's a doctor. I mean, that's what doctors make. Engineer, I don't know, man. I can tell you, I think I would. There's a part of me that wishes I'm young enough where I'm still thinking heavily about going and becoming an electrical guy. But I don't like the idea of playing with, I mean, if you've ever been shocked before, like really shocked, like I was fixing one of my outlets one time, and I was an idiot and had a metal screwdriver and touched the part I shouldn't have touched, and it sent like a jolt all the way up through my arm, and I'm like, yeah! Like Maddox's dad, and does anyone else's dad work for Garcane? I know, of course, yeah. You guys, I'm sure if those guys got shocked, they're dead. Because the power they're working with is far greater than a power that.
Like 130 feet.
Yeah, if they get shocked, they're in a dark place, right? If my brother-in-law gets shocked, I mean, it could rock him. He said he was working they were building a brand new church. He lives up in Eagle Mountain. They're building a brand new church, and he was wiring it, and it has stairs. And he was up there wiring this chandelier in. His partner had turned on the breaker, and he yelled power on, but you're not supposed to have headphones in during this job, but he didn't hear it. And he was sitting there, and he touched him, and it said it flipped him completely upside down off the ladder and fell like a story and a half downstairs. And he says his partner came in, he's like, "What are you doing on the ground?" He's like, "I can't feel my back." But I wouldn't do, if Wes decided to touch outlet, or those guys decided to touch outlets, they're in a dark place. That would probably shoot them 30 feet into the air. Your assignment's there, 11-2, I think I called it, or 11-1. It's 11-1 and 11-2 combined, so. Your dad ever been shocked, Maddox?
Yeah, all the time.
Like-
whenever you climb up, it's like your whole body's getting shot.
When you're climbing up it?
No, just being around the wire.
Oh, you can feel it? I watched a guy climb up those great big ones out in California that you can actually hear the buzzing on them. And they have to climb up like with really special gear and stuff like that, because they said they can like feel it up there, like severely, like.
Like it hurts.
Yeah.
It just hurts. It's weird.
What about you, Cooper? Wes ever been shocked real good?
No, but he told me stories about
What about you, Brian? Your dad, Cora?
No, he's the engineer. So.
Oh, he's got the good job. He's what my brother-in-law wants to be. He wants to be on the ground being like, "You climb up this pole." He's not the guy that gets shocked. He's the guy that tells the people where to go get shocked. Right?
Yeah.
Anybody else's dad an electrician?
My dad sometimes works on like.
I think I want to go become an electrician. The problem is I don't have enough. I'd have to start all the way up. College and that would not apply to electrical.
Are you sure?
I can tell you that mitochondria is the powerhouse of the cell, which is kind of electrical. What?
Never mind. I just.
Are you kidding me? Brent, how are you?
Good.
He says he hates working in old homes. Hates it with a passion. And my house isn't that old, it's only 1980s. 1980 was built, but he hates working in old homes. Says the wiring's always like, the way they wired houses back before like 2005 is way different than they wire the houses now.
What are corresponding angles? Just cover them. You're still recording.
Still recording?
Okay. 30 minutes of video about electricians.
Look at it.
That's a good video. Hey, I like telling clients that